Alright, in this video 6.1, so we're going to discuss the addition formulas. So the addition formulas are formulas that concern sine, cos, and tangent. So when two different angles are being added or being subtracted from one another. Okay, so this is how the formula is going to look like. This is going to be for the case of sine and also cosine. Okay, so you don't actually have to memorize this. So this is actually in the formula book if you need to refer to it, or you can refer to the slide as well. So if you have something in the form of sine of A plus or minus B, so when you have a symbol that is being put together here, so it means that this is applicable for both plus and also minus. Okay, so when you have sine A plus or minus B, so sine A, for example, sine A plus B is going to equal sine A cos B plus cos A sine B. And for sine A minus B, so that is going to be sine A cos B minus cos A sine B. So what happens is that how do you read the formula? So it's going to be something like this. So what goes on top? So if I have A plus B, on this side, it's also going to be plus because both are on the top of the symbol right there. And when I have sine of A minus B, so in this side is also going to be minus. But for the formula of cos, so it's going to be the other way around. So when I have cos of A plus B, so that will be cos A cos B minus sine A sine B. And when I have cos A minus B, that is going to be cos A cos B plus sine A sine B. Okay, so top is going to be paired up with top on the other side. Bottom is going to be paired up with the bottom. Okay, so we can have a look at this for example. So I'm going to show you. So how do we actually use the addition, the addition formulas in order to simplify, prove, and do all these questions that we have over here for the examples. So there's going to be 4 in total. So let's start with the first one. So the first one, what we have to do is simply simplify. So you have to simplify the expression cos 2 theta cos theta plus sine 2 theta sine theta. When the question says simplify, so meaning that instead of like having two different terms separated, so this is two terms, this is one term, this is another term. So what you have to do is you have to make it in the simplest form that you could and make it into one term only, the simplest way could be. Alright, so if you have a look over here, so I have this in the form of cos multiplied by cos, sine multiplied by sine. So the formula that would fit that case would be the top one, so which is going to be cos of that. And because I have a plus sign, so which is what I have at the bottom here, so therefore it's going to be cos of A minus B. So let me copy the formula and compare it to what we have over here. So I'm going to have cos A cos B plus sine A sine B. So according to the rule, so that is going to equal cos of A minus B. And when I have a look at the form that we have over here, so what is going to be A? So this over here is going to be A, and this theta over here, so this is going to be B. So therefore, if I were to simplify, I can write that cos using this formula, cos 2 theta cos theta plus sine 2 theta sine theta. So that is actually going to equal cos of A, so which for this case is going to be 2 theta minus B, which is going to be theta. And of course I can simplify whatever that I have in the bracket right there and have this written as cos of 2 theta minus theta, which is going to be theta. So that is the simplified form. So basically cos 2 theta cos theta plus sine 2 theta sine theta can be simplified to cos of theta. That's it. So that is going to be the first example. So it's a very simple one. And the second one, so here we're going to prove that cos pi over 2 minus alpha, so that is going to equal sine alpha. So somebody actually asked me before, like one of you actually texted me and asked me, like if you have something that you have to prove, you have two equations on the left hand side, right hand side. So this is the left hand side and this is the right hand side. Do they have to be the same? Yes. When the question says prove, it means that that is actually a true statement. So the left hand side must be equal to the right hand side. If you don't get an equal, so there's something that you haven't, that there might be something wrong with the way you calculated that. Okay, so of course I did mention this to you before in the previous topics, the fact that when you come across something that you need to prove like this, so start with the more complicated one and make it into the simpler form. And the more complicated one is going to be this over here, so which is cos of pi over 2 minus alpha. So let's copy the formula for cos of, so if I have cos of A minus B, that is going to equal cos A cos B. So that's a minus at the bottom. So that I'm going to have plus sine A sine B. Okay, now I'm going to start substituting. Okay, for this case, what is going to be my A? So my A is going to be given by pi over 2, and B is going to be given by alpha. So when I apply the formula, so I will get that cos pi over 2 minus alpha. So that is going to equal cos of A, so which is going to equal cos of pi over 2, cos of B, so which is going to equal cos alpha, and plus sine of A, which is going to be sine pi over 2, and then sine of B, which is going to equal sine alpha for this case. Okay, and of course that you can actually simplify this, so using your calculator, so you can actually figure out what is going to be cos pi over 2 and sine pi over 2. So it's actually a special angle as well. So if you have a table that you can refer to, so either you can use the table or you can use the calculator. Calculator would be the easiest way. But remember, before that, you have to change your calculator and make it into radian unit. This should not be in degree, but should be in radian. So cos of pi over 2, so according to calculator, so that is going to be a value of 0. So this is going to be 0 multiplied by cos of alpha plus, and then we have sine pi over 2, so according to the value from the calculator, so sine pi divided by 2, so that is going to be a value of 1. So that is going to be 1 multiplied by sine alpha. Of course, when you have 0 multiplied by anything, so it's going to be 0. So this expression is going to be simplified to sine of alpha. So therefore, we have proven that the left-hand side is equal the right-hand side. Okay, so I'm going to write over here. So therefore, proven. But you don't need that. You can also just, ignore that and prove that it's actually just equal sine of alpha. That's it. You're done. Okay, and then let's have a look at the third example. For the third example, the question said use the special angle. That will be the keyword. You have to be referring to the special angle, and you have to determine the exact values of cos of 15 degree. So what are special angle? So there are, how many values are there for special angle? So you can have a look over here. So this is the table that I gave you before. So this is for topic 4.3 if I'm not mistaken. So these three are called as being special angle. So basically we have 30, we have 60 degree, 45 degree, and we also have, what's the other one? 30 degree. Okay, so you have to find a combination of these numbers that would create a 15. But there's going to be multiple ways of doing this. First, you can actually pick a cos of 60 degree minus 45 degree, because we know that is going to equal 15. Or you can also pick cos of 45 degree, so minus 30 degree. So that is also going to give you cos of 15. So either way you pick, so whether you use this one or this one, both of them are supposedly going to give you exactly the same answer. I guess you can choose either way. For example, let's say I'm going to choose the top. I'm going to write that. So basically cos of 15 degree is actually equivalent to cos of 60 degree minus 45 degree. And according to the rule that we have over here, so we have cos of A minus B. So that is going to be cos of A, so which is going to be cos of 60 degree minus multiplied by cos of B, cos 45 degree. So when I have minus, so on this side is going to be a plus. So I'm going to have plus, so sine of 60 degree multiplied by sine of 45 degree. Okay, let me open this in a new window so we can easily refer to these values. First, I'm going to have at cos of 60 degree. So this is 60 degree. So I need the cos. So according to the table, cos of 60 degree, so referring to this one, so that is going to equal a half. So I'm going to have a half multiplied by cos of 45 degree. So this is 45 degree. Cos of that is going to equal square root 2 over 2. So that is going to be the value. And plus, then I'm going to have sine 60 degree according to the table. So that is going to be square root 3 over 2. So multiplied by sine 45, and sine 45 is going to equal square root 2 over 2. Okay, so those are going to be the values. So let's close this. We don't need this anymore. And now we can simplify our answer. So for the first term, I have multiplied by square root 2 over 2. I will get a square root 2 over 4 plus on this side, I'm going to end up with a square root of 6 over 4. So I can write that this is going to equal square root 2 plus square root of 6 over 4. No need to simplify. So just leave it like this. Even if you leave it like this, so that should be fine as well. So let me check the values again. 4.3, 4.4. Yeah, when it's 45 degrees, it's going to be square root 2 over 2 and square root 3 over 2. That's right. There's nothing wrong with the calculation. Okay, so that is going to be the outcome. So no need to simplify that. No need to find what is going to be the value in terms of decimal places, like it's going to be 0 point something something. No, we don't need that because the question asks you to find the exact value. So if it's exact value, so meaning that, for example, 1 over 3, what is exact value? So 1 over 3 is actually 0 0.33333 until the end, until infinity. But if you take it only like 3 decimal places, so that is not exact value. So exact value is going to be 1 over 3. So that is called as being exact value. So that is why for this case, so you don't need to change this to decimal places. So this is going to be our exact value. Alright, so example number 4. So the question said that if sine S is equal 3 over 5, so where S is in the first quadrant. Why do I know this is going to be in the first quadrant? Because it's positioned between 0 and pi over 2. So that's first quadrant. And sine T is going to equal negative square root 3 over 4. And that is going to be positioned in the third quadrant because it's from pi until 3 pi over 2. So the question asks you to compute what is going to be sine of S minus T. Okay, so now what I'm going to do is I'm going to sketch this in the respective quadrant 1 and 3. Okay, so in the first quadrant I have S. So let's say this is going to be our S somewhere over here. So sine, it's going to be given by sine is equal opposite over hypotenuse. So the opposite value is going to be 3. The hypotenuse value is going to be 5. So if you use the theorem of Pythagoras, you'll be able to figure out this is going to be a value of 4. So that is going to be for the S angle. And then we have another angle, so which is positioned in the third quadrant. So it's going to be somewhere over here. So it's going to be given by T. And for the case of T, so the opposite is going to be given by a value of square root 3. And the hypotenuse is given by a value of 4. Okay. And if I wanted to know what is going to be the value for the adjacent, so I can write that. So the adjacent value is going to equal 4 square minus square root 3 square root. And that is going to equal 16 minus 3 square root, which is given by a square root of 13. So it's going to be square root of 13 right here. Okay, so now that we have all those information, so I'm going to apply the formula. So what is going to be sine of S minus T? So according to the formula that we have at the top, so it's going to be sine of S cos of T. So I'm using the formula at the top for sine. And when I have minus, so on the other side is going to be minus as well. And then I'm going to have minus, so cos of S and sine of T. So it's going to be the inverse of what I had previously. Okay, so now I'm going to start using the formula. So I'm going to have sine of S. So this is my S. And I would like to remind you the fact that the rule of CAST, so C-A-S-T, okay, we're going to apply this as well. For the case of sine of S, so anything that is in the first quadrant, sine, cos, or whatever that is always going to be positive. And sine of S is going to be given by 3 over 5. So that's given in the question. So I'm going to have 3 over 5. And cos of T. So remember, in this third quadrant, only tangent is positive. So I'm supposed to have a negative value for cosine. So cos is going to be K adjacent over hypotenuse. So that is going to be given by negative square root of 13 over hypotenuse value. So which is going to be 5. So minus. So cos of S, again, it's going to be K adjacent. So I'm going to have 4 over 5. and sine of t is given in the question, so that is going to be negative square root 3 over 4. So now let's simplify this. So at the top, I'm going to have negative 3 square root of 13 over 25 minus, sorry, it's going to be a plus, and then I'm going to have 4 square root of 3 over 20 for this case. Okay, so you don't need to simplify, you can just leave it like this. Okay, because if you simplify this, you might get your answer in terms of decimal places. So no need to, just leave it like this. And this is going to be sine